This is the simplest bit of math I know that's still vaguely interesting. If you met a random stranger who doesn't care about math, and you had to show them some proof, something really simple that they're likely to appreciate, then maybe this would do nicely. Hi there, I'm Y and this is a math video. For the 520 of you who weren't expecting that, don't worry, this is going to be a one-off thing. I'm making it for this year's Summer of Math exposition, just for fun. And even if you're not into math, you might want to stick around. It's not gonna blow your mind, but anyone who can add and multiply numbers can understand this. No special concepts needed. So here's a very modest number trick. Say we have a 2-digit number. Well, yeah, we could use that one, but let's say 73. And then we reverse it, swap its digits, so 37. Now, what's the difference between these two numbers? The larger minus the smaller, 73 minus 37. Well, there's a nice shortcut. Simply take the difference between the two digits, 7 minus 3, which is 4, and multiply that by 9. 4 times 9 is 36, and that is indeed the right answer. 73 minus 37 is 36. And that's the trick. And it works for all 2-digit numbers. The difference between a number and its reverse is just the difference between the two digits times 9. Here's another example. Take 82 and its reverse, 28. What's the difference? 8 minus 2 is 6, and 6 times 9 is 54, so the answer is 54. No 2-digit subtraction needed. Impressed yet? No? Well, I did say this wasn't gonna blow your mind. It's not much of a shortcut if you're good at mental arithmetic. But I'm not, so this trick has actually come in handy a couple of times. For example, someone born in the year 1958 turned how old in 1985? 8 minus 5 is 3, 3 times 9, so 27. I came up with this trick myself back when I was in school, but I'm probably not the first and definitely not the only one who found this. For instance, there's a recent video from Mind Your Decisions that shows a more general fact. The numbers can be as long as you like, and you can rearrange the digits in any way you want, and the difference will still be some multiple of 9. Still 9 times something. Back when I found this trick, I couldn't explain why it worked. I didn't have a proof for it. But like I said, it's actually pretty easy to prove. Proof number 1. This is the boring way. Just write down all the 2-digit numbers and check if the trick works for all of them. It does, but it's not very satisfying. It doesn't give us any new insights. Proof number 2. A little bit of calculation, but we'll be done before you know it. Say we have some 2-digit number. Let's call the first digit A and the second digit B. How do we express this number? Well, A is in the tens place, so we have 10 times A, and B is in the ones place, so plus B. In the reversed number, we have B in the tens place and A in the ones place, so 10 times B plus A. Now what's the difference? 10A plus B minus 10B plus A. Remove the brackets, the right brackets are being subtracted, so we swap a plus inside for a minus, and now things cancel out. We're adding 10A and taking away 1A, that makes 9A. We're adding 1B and taking away 10B, that makes minus 9B. Factor out the 9 and now we have 9 times A minus B. We started with the difference of the two numbers, and after shuffling the symbols around a bit, we found that it's the same as the difference of the digits times 9. Proof number 3. Let's think about the difference as how far apart two numbers are, what we have to do to get from one to the other. Imagine a ladder with, say, 73 on the top and its reverse, 37, on the bottom. On the left side, we count down the digits one at a time. On the right side, we count up one at a time, until we get to 37. This takes 4 steps on the ladder, because 3 and 7 are 4 steps apart. So what are we doing? To get from a number to its reverse, count down the left side by 1 and count up the right side by 1 as many times as needed. Now the left side is of course the tens place and the right side is the ones place. Removing 1 from the tens place just means subtracting 10, and adding 1 to the ones place means, well, adding 1. So in each step on the ladder we subtract 9. And how many steps do we take in total? As many as we need to get from one digit to the other, so the difference between the two digits. And so, the difference between a number and its reverse is 9 times the difference between the digits. And there we have it. By the way, how can we be sure that we even get to 37? Along the way we come across 64 and 55, but not, say, 52 or 39. Maybe we won't come across 37 either. But that can't happen because the digits are the same, just reversed. The pair of numbers on the left is the same as the pair on the right, so the counting takes the same number of steps on both sides. And that's actually important, making sure the steps are valid. Am I allowed to do this? Yes, because... And that tends to give you a better sense of the conditions, when the trick works and when it doesn't. So maybe you're not into math and you've just learned a new trick. Or maybe you like explaining math to people and you've just found something very simple to explain. When it comes to proofs that are shown to the general public, the go-to examples are things like root 2 is irrational or there are infinitely many prime numbers. But to the uninitiated, I think they take a lot more for granted than you might realize. Lowest terms can't be written as a fraction, an even number squared is even, proof by contradiction, or what even is a prime number. That may be very clear to you, but I know people who don't know what prime numbers are. They've heard the word, but they couldn't say why 7 is a prime and 8 isn't. This last proof may be more accessible, and it still has a lot going for it. Seeing things from a new perspective, justifying actions, applying a definition, and it only involves adding, subtracting, and multiplying. Nothing more. I'm just saying, maybe we tend to overestimate what the average person cares about. And maybe there's some value in a very modest proof. Or maybe not. You decide. Very kind of you to watch. This used to be a Mario ROM hacking channel, and I'd like it to be a game development channel sometime soon, so I'm not planning to make regular math videos. Either stay tuned or don't, depending on your preferences.